Okay, we're going over the 6.3a quiz. You guys took this in class already. Just want to make sure you guys understand the answers to all the questions. So the first question said, a recent survey asked 100 randomly selected adult Americans if they thought that women should be allowed to go into combat situations, and here are the results. So you've got a table. Part A says we need to find the probability of a yes answer given that the person was a female. So I'm going to first look at all the females and see that there are 8 plus 42, so there's 50 total females. And out of those 50 females, 8 of them said yes. 8 out of 50 is 0.16. Part B, find the probability that the respondent was a male, given that the response was no. So first we're looking at all the no's. You're going to add these up and you'll get 60. And 18 of them were males. So there's 18 out of 60, which is 0.3. And each of those questions was worth 1 point. Question 2 says you're going to toss 2 balanced coins. Let A equal a head on the first toss and B equal both tosses have the same outcome, which means they could be 2 heads or 2 tails. And they want to know if events A and B are independent, and then explain your reasoning clearly. So the first thing you need to think about is, if they're independent, what is a formula that talks about independence? So I went back to the notes and I looked at the fact that the way you test to see if 2 events are independent. And so that formula says the probability of B given A is equal to the probability of B. So the probability of B, where both tosses having the same outcome, the way I figured that out is I made a Punnett square over here. So one toss, you could either have a head or a tails. The other toss, you could either have a head or a tails. Filled in all the things. And I saw that there were 2 events where we had the same outcome, 2 heads and 2 tails. Out of 4 total events, 2 out of 4 is 0.5. So I know the probability of B is 0.5. And then the way you find the probability of B given A is this formula that says the probability of A intersect B divided by a probability of A. So I had to take the information that I knew about tossing a coin, which means that you either have a 50-50 chance of getting heads or tails. And I made a Venn diagram over here to figure out what the intersection would be based on the values that I knew. So I know that the probability of A is 0.5 because that's heads on the first toss, and you know that half the time you're going to get a heads. So the total sum of all the values that fit inside A needs to add up to 0.5. But I also know the chances of B happening, because I already calculated that, is 0.5. So the total percent that needs to be in the B circle is also going to add up to 0.5. So the trick here is figuring out, what's this overlap amount? What's A intersect B? And so the way you figure that out is you're thinking about, what are the odds that the first toss is heads and both tosses have the same outcome? When do these things happen at the same time? And obviously that happens at the same time if you have a heads and then another heads on the second toss. And that happens when you get heads on both tosses 1 out of 4 total times. 1 out of 4 is 0.25. So I know the overlap, the A and B happening, is 0.25. And since the probability of A is 0.5, I have to figure out this number here. So 0.25 plus what gives me 0.5. And so obviously I can tell that that's another 0.25. And similarly for B, since I know that B is 0.5 total, and I know the middle is 0.25, that means this section over here that's not in the overlap but still in circle B is also going to be 0.25. So once I've set up this Venn diagram, I can fill in these values over here for the formula. So I know that the probability of A intersect B, or A and B happening at the same time, is 0.25. And if I divide that by the probability of A, which is 0.5, I get 0.5. So the probability of B given A is 0.5. I put that in up here. I know the probability of B happening is also 0.5. Because I get the same value, that means that these 2 events are independent. That question's worth 2 points. Question 3 says, parking for students at Central High School is very limited, and those who arrive late have to park illegally and take their chances at getting a ticket. Joey has determined that the probability that he has to park illegally and that he gets a parking ticket is 0.07. He recorded data last year and found that because of his perpetual tardiness, the probability that he will have to park illegally is 0.25. Suppose that Joey arrived late once again this morning and had to park in a no parking zone. Can you find the probability that Joey will get a parking ticket? If so, do it. If you need additional information to find the probability, explain what is needed. So I set up a Venn diagram again for this problem. And my two events here are whether or not he parks illegally and whether or not he gets a ticket. And they told me in the problem that the probability of him parking illegally and getting a ticket is 0.07. So I know that when he does, so both events happening at the same time, that probability is 0.07. That's your overlap that goes in the middle. But I also know that the chances of him parking illegally is 0.25. So I know the whole circle needs to be 0.25. If this piece is 0.07, this piece over here is whatever you add to 0.07 to get 0.25. And so I found that was going to be 0.18. And then you wonder, well, what goes over here? How could he get a ticket if he doesn't park illegally? Well, if he doesn't park illegally, he's not going to get a ticket, so there's nothing over here. So in this diagram, if you add up all these numbers, you get 0.25 total, which means 0.75% of the time, or 75% of the time, he's parking on time. He's parking legally because he's getting to school on time. He's parking in a parking zone where he's allowed to park. So we are trying to find the probability that he gets a parking ticket. So he gets a parking ticket when he parks illegally. So you're looking for what's the probability that he gets a ticket given that he's parked illegally. That's another conditional probability. So again, we're using the same formula that we did for number 2. So that's defined as the probability of parking illegally and getting a ticket, which we know is 0.07, divided by the probability of parking illegally, which that total is 0.25, which they gave you. You divide those, you get 0.28. So that's the probability that Joey is going to get a parking ticket. And again, this question was worth 2 points. And the last question, number 4, says 2 cards are dealt one after the other from a shuffled 52-card deck. Why is it wrong to say that the probability of getting 2 red cards is a half times a half, or just 1/4? What is the correct probability of this event? So when you're shuffling and you're dealing cards, you are not replacing them after they're being dealt. So the probability of getting a red on the second card, say the first card that you deal is black. So if the first card you deal is black, then the second card, there's still 26 red ones, but there's only 51 total cards. Or if the first card that you deal is red, there's 51 total cards left, but now there's only 25 red cards left. So if you're looking for the probability of getting 2 reds, the first red, yeah, there's 26 out of 52. That's half the deck is red. That's fine. But the second thing is, if you've gotten a red on the first one, then there's only 25 reds left and there's only 51 cards left. So you don't multiply by a half again because the probability has changed because you don't have as many cards left and you don't have as many red cards left. You multiply these two things together, you get 25 over 102, which is 0.2451. So this is wrong because they are not replacing cards. If they were replacing cards, this proportion would be correct. This one was worth 2 points. So the total on quiz 6.3 is out of 8 points. If you didn't understand anything on the quiz, come back here and make sure you go over it, and hopefully you'll understand all the questions.